Hello everyone, this is Venugopal. Today in this session we are going to see the bitwise operators in C language. Let us understand what exactly mean by this bitwise operators. So our topic is bitwise operators. Before going to see what are the various bitwise operators available in C language, let us understand some basic fundamentals here. So whenever we are talking about programming language, this programming language is always we are doing in high level language, high level language. But in my earlier videos, in the beginning of the C programming, I told you that whenever we are doing the programs by using this high level language, this language has to be converted into machine language. Machine language, because machine can understand only machine language. Whenever I'm saying the machine language, that language is nothing but a binary language. So ultimately whatever the input we are giving to the machines, there has to be a conversion to this binary language, because binary language only understandable by the machines. So binary language means what? The language which is written in the form of 0 and 1 only. So for example, if I'm going trying to suppose add this 8 plus 4, consider this 8 plus 4. This 8 plus 4 is not directly going to be understood by the machine. So there has to be some equivalent binary code for this 8. Suppose if I want to write this 8 in the binary form, so the format would be like this, and then 1 0 0 0. This is what? This is the binary number. This is a binary form of this decimal number 8. Similarly, if I want to write the equivalence for this 4 number in binary form, so then 4 zeros, then I'll write here 0 1 0 0. This is the binary form of 4. So internally, whenever we are dealing with this kind of stuff, we are giving the input as a 8 and 4 in the decimal format, but internally it will be converted into this binary format. And then this addition will be takes place, right, with this binary format only. And the result will be written back to the decimal part. And that's what we can able to see with the help of the translators. In a high level language, like compiler and interpreter, these are the translators which acts as an intermediator between the programmers, or we can say that we and the machines. So then this will be added in the binary form only, and then the result will be back to the output screen. So how actually I have written this all stuff? Basically what happened, whenever I'm writing this, that means what? Here this is 2 to the power 0, because it's a binary. We are converting into the binary. So 2 to the power 0 is what? 1. 2 to the power 2 is what? Sorry, 2 to the power 1 is what? 2. 2 to the power 2 is what? 4. The next is 8. 2 to the power 3 is 8. 2 to the power 4 is what? 16. Then 2 to the power 5 is 32. Then 64. Then so on. So whenever I'm writing this is the equivalence of this particular binary form, whatever I'm writing here. So here, where this 8 stands, see, 8 stands here. That is the reason why only 8 will have this 1 and the rest of the things are 0. Okay, if I want to write 4, see, only in front of 4, I've taken this as 1. I hope you're getting. Here I have given 1 in place of this 8. So because this is 8, right? Now here I want to represent 4. So here I have written wherever the number exists, just we write down what? 1 here. For example, if I want to write 10, Are you able to figure out how to write this 10? It's very simple. 4 times 0, 0, 0, 0. Addition of this 8 plus 4. See, 8 plus 2 is 10. That means here 1 and here 1. Rest of the things will be 0. So 1, 0, 1, 0. This will be the representation of 10 in binary form. So to deal with this, this is called as what? This is called as a binary form. Or you can say that this 1, 0 is 1 bit, second bit, third bit, fourth bit. Okay. So whenever we'll calculate 8 bits, these are the 8 bits representation. 8 bits representation is nothing but it is 1 byte. It is 1 byte. So whenever we are taking a byte, that means what? It is a representation of 8 bits number. That is the reason why I'm writing here in a 8 bits. If it is a 2 bits or 2 bytes, then I have to write a 16 bits number. This is what the calculations of this binary form. So to represent this binary numbers and to perform some operations with this binary bits, okay, we are going to use some bitwise operators. So bitwise operators basically they are used to they are used to perform operations on bits. So there are a number of bitwise operators available. For example, and this is called as bitwise and. Similarly, bitwise, this is OR. The difference between logical and bitwise AND is in logical AND we will use two ANDs, two ORs, but here we'll use only one AND, one OR. It's called as what? Bitwise OR. Then this represents bitwise XOR. Then this represents complement. Bitwise complement. Then this is called as left shift operator. And again, this is called as a right shift operator. Okay, I'll tell you the explanation of this all operators, how they are going to be perform or how they are going to be work. Bitwise AND means, let us take here, it returns 1 when both the bits are 1 only. That means it return 1, right? Whenever the corresponding between what bits are 1 only. Okay, if 1 1, then the result will be 1. Okay, then here we'll see it returns 1 when either of the bit is 1. Not require ki both the bits would be 1 only. I will tell you practically, don't worry about that. And then bit XOR. So bitwise XOR means what? It uh, returns 1 when both the corresponding bits are opposite. Opposite means what? If one bit is 1, then other bit should be 0 only. Then bitwise complements. Bitwise complement means what? It returns 1. Bitwise complement is a unary operator. It is not a binary operator. So it returns 1 if bit value is 0 and vice versa. Vice versa means what? If bitwise value is 1, then it returns 0. If it is 0, then it returns 1. vice versa. Now left shift. Left shift means what? Bits will be moved left side, uh, what we can say, left side, uh, by specified number of shifts, depending on the user how many position or by bits they want to shift. Similarly, here right shift means it will move to the bits will be moved right side, and the number will be given by the user how many bits they want to move right side. So we'll take one by one example to understand in a simpler way. First of all, we'll take like a bitwise and. Okay, so for to understand that thing, what we will do, we'll take the same number here. For example, 0, I'll just make a space to understand more clearly. 000. This number is what? This is the binary form of 8 number. And then I'm taking the another one, that is 4. So here it will be 0, then 1 and 0. This is the form of binary form of 4. Now, and whenever if I'll do and, for example, this is a equal to 8 and b equal to 4. And I want to do what here? I want to do 8 and 4. For example, here I'll write. So, how this and is going to be performed? It returns 1 when both the bits are 1 only. So, if we do this here, right? What is the situation here? 0, 0. See, this is 0, this is 0. The answer would be 0. Again, 0, 0, 0, 0 only, 0 only. Right? 0 and 0 only. The result will be 0 only if I'll do 8 and 4 here. I hope you are getting right, because there is no number is there, right, which will match here. For example, if this bit is 1, so this has to be 1 only, then only it will be calculated. Otherwise, the entire thing will be 0. Suppose instead of this one, if it has 1 here, the output would be like this now. Okay, so this is what the result of what 8 and 4. Okay, so what we will do one short exercise by using the program, and let us try to find out the solution. Bitwise operator. In the bitwise operator, we are seeing what logical and first. This is for, I'll not write here because in the same program only I will do all the stuff. Include stdio.h void main, and suppose I am declaring here a is equals to 8 comma b is equals to 4. That's it. And I want to printf. And suppose if I print here, I want to print what? A and B. Suppose I want this. Okay. Uh, and this is percent %d, comma. I want to print A and B. Okay, so let us check what would be the output. Before that, I need to save this program. Then here I'll write like a logical, no, not logical, I'll say only bitwise operator. See, the result is 1. Mm, How the result is 1? Just to check the answer. A is equals to 8 and B is equals to 4. Okay, so if I'll do the addition here, This is 8. 8 0. 8 4, because the bits are not same here. If I'll talk 8 plus 8, just to take, uh, okay, this is okay. This result is okay, right? Because 1 plus 1, 1 1, the answer should be 1 only. Okay, but if I'll take another number, suppose I'm taking this b as a 2, for example. Okay, so the answer must be 0. Mhm. Oh, sorry, I'm taking here double. That is logical and. Oh, it's my mistake. Okay. So see, is 8 and this is 2. So definitely, so I'll take the 4 number first. Okay. And see if I'll do A and B, the result would be 0, right? But if I'll take 8 and 8, you will get the result what? 8, because 1 1 is 1. Yes or no? Ha, don't get confused. See the answer here. If it is both the numbers are 8, it is 0. And suppose I'm taking this as a 1. Okay, so what this logical AND will return? 1. When it will return 1? When both the bits are 1. So this bit and this bit is 1 only. Okay, so this will return what? 1 here. Okay, and if you read this carefully, this is 1, 2, 4, 8. Right, so that is the reason the result is giving what? 8 number. For example, if you're changing, suppose I want to take 1 here, 1 more. So this number will become what? 10, right? Yes, sir, this number will become 10 plus this one. So your answer will be what? Again, only 8 only. Okay, check the answer. If this is 10 and I'm doing the same stuff, it will return 8 only. Because logical and will return, oh, sorry, bitwise and will return only 1, right? 1 means when both the numbers, when both the bits will be 1 only. This is what the bitwise calculation. Okay, so don't get confused here. Okay, in the second statement, see, in bitwise OR, if any one of the one is 1, any one of the bit is 1, then it will return 1. So if I'll do the addition again, suppose I'll take the same number, 8 plus, suppose I want to add 4 now. This is 0. So 4 means what? This number, right? Now, first one is 8. Sorry, extremely sorry. For example, I'll take few more numbers, 0 0 0 0 and 8. No, so 8 means 1 0 0 0. This is 8. In bracket I will write 8, and then I want to add with a, suppose, 4. So 4 means what? This is a 4, 1 0 0. So this is 4. Okay, now what would be the result here for OR? Right? If any one of the bit is 1, then the result will be 1. So here both the bits are 0. So answer is 0. Both the bits are 0. So answer is 0, 0, 0. But here one bit is 1, another bit is 0. But the answer is 1. Then one bit is a 0 and second bit is a 1. But the answer is 1 and 0, 0. That means if I'll do 8 and logically 8 and 4, my answer would be what? This is 8 plus 4. The answer would be 12. So let us check. Go here and same thing. Suppose this is 8 and suppose this is what? 4. Okay, so my answer would be A. If I'll do A or B, bitwise OR. This is called the bitwise OR. Okay, if I'll do C, the answer is 12 because it's doing the calculation with bits, not with the directly decimal numbers. Okay, the next is what? XOR. Next operation is what? Bitwise XOR. That means what? It should the if the corresponding bits are opposite, then it returns one. Okay, so in this case, these are opposite, so it returns one. These are opposite, it returns one. Suppose these are both are same, one and one. It returns what? Zero only. So which is this number now? This is 8 plus 4, 8 plus 2 means 10, and this is 4, 2. That is 4, 2. 4 plus 2 is, this is 6. This is 10. Okay, so we'll provide 10 and 6. Then the answer would be 10 again. Okay, 10 and I'm providing 6. But the operation would be here XOR now. So what XOR will give? XOR will give if both the bits are opposite corresponding bits, then it will return 1. So let us check the output. See, 10 plus 6 is also returning 10, 12 because see here, these two bits are opposite, 1 and 0. So that is the reason why it is giving 1. These are opposite. That is the reason why it is giving 1. But these are same. So if it is same, it returns 0. If it is different only, then it is returns 1. Yes or no? Already we have seen. Already we have seen here in the bitwise or it returns 1 when both the corresponding bits are opposite. Then this is a complement. Complement means what? It will convert all zeros into 1, 1 into 0. Okay. For example, for example, let us try this one. Suppose I'm taking any number. For example, 1, 1, 1, 1. I'm taking 0, 0, 0, 0. Okay. But if I'll put this complement, okay, what happened? This all 1, 1 will become, for example, complement. I want to perform this complement bitwise. What it will return? 0, 0, 0, 0. Then it returns 1, 1, 1, 1. So the result is what now here? The result is 12 here. But what is this number that we should know, right? So this is 16, 32, 64, 128, I think. Okay, so if I'll add that one, that all numbers, we'll do that also. Okay, yeah. I think 16 plus 32 plus 64 plus 128. This might be 240. So let us try. Okay, so we'll give this A equal to 240 will give and leave this part now. We don't require this. And here, just I want to print a complement of A. Okay, here I want to just print the complement of A. We'll see what it will going to return. Oh, it's returning just adding the bit and it's returning the -1. 240, it's returning 241. Hmm? A equal to 240 would be the correct number or not? I don't exactly know. But suppose if you take any number, right, it will return the reverse of that particular number. Uh, 2 into this is 8, 16, 16, 32, 64. 128 is the correct number. Again, 128. plus 64 plus 32 plus 60. It's 240. Uh, Anyway, suppose if I'll give like mm, just to check, okay, uh, 0 1 0 1 and all suppose 0 0 0 0. So it will be returning what? Complement 1 0 1 0 1 1 1 1. Okay, so what is this now here? This is 8 16 plus 16 plus 64 means 80. Okay, so let us give 80 here. Complement of A 81. It's giving a negative number. The conversion. Okay, anyway, okay, fine. We'll go to the next part, but remember carefully the calculation will be actually whenever we are doing this complement, there is a ones complement and twos complements funda is there, right? We will try to cover in the any another video of that because the calculation of these complements will be slight different than the whatever we are seeing here. Okay, so better we cover this left shift and right shift here. Okay, so left shift, right shift means what? I told you already. Left shift means whatever the bits you are giving. For example, if this number is for example taking this number only, we'll take 8 number. So 0000 and 1000. If I want, for example, this number, what is this number? 8 left shift by 2. That means what? It will be shifted 2 positions to the left side, right? So what will be the change now? 0010, getting then 0000, because these two digits are shifted to this place. That is called as the shifting of bits. Okay, and in the right shift what happened exactly? If we'll give the right shift, for example, uh, I want to shift this, for example, in place of 8 left shift to, I want to 8 right shift to. Okay, the same number, the first number I'm telling, making changes on this first number. So answer would be what? Right shift. Okay, so 0000, then two zeros will be added. Then this will be shifted to 2 digits right side. See, 2 digits, it is shifting to the right side. Okay, so shall we check? And if it is shifting, that means the equivalent decimal number will be naturally its change. Okay, for example, we'll see the program. Suppose I'm taking this one as a 8. So binary number you know now very well. Okay, and here suppose I want to do what? This 8 number left shift 2. I'm printing. Okay, and here I'll write what like A left shift 2. Okay, so we'll check what is the exact corresponding number of this one. Let us check. Are you getting 32? Now see the diagram here. Come to this one. 8 shift 2 I've done. Okay, this is a normal number. This is the normal representation of 8 bit, right? I've shifted left 2 digits. So shifted means what? This 8 place will be shifted to 16. Then it will be shifted to this position will be 32, right? See at the top we have already seen. See, this is the 32. This 8 is shifted to 2 bits earlier, left side. So that number will be 32. That is the reason why you're getting the answer is what? You're getting the answer is 32. Got it? That is called as the left shift. Okay, if I'll shift 1, the answer would be 16. Yes. Okay, if I'll shift right side now here, right shift. and I will shift by suppose 1 only, right? Shift by 1 only. Now see the number here. If this is a normal number, right? This is a normal number. I want to shift one side, this one. So it comes here. So equivalent number is what? The answer should be 4 here. Okay, so let us check. If it is 4, then our concept is clear. Okay. See, it's a 4. If I shift one more, the answer is 2. Right? So this is what the usage of your bitwise operators. We have covered all the operators, right? Except one operator we have, the definition is perfectly fine of this complement, that it will be reverse with the, if it is 0, then it will be converted to 1, and if it is 1, it will be 0. But there would be a deep depth concept, that is one's complement and two's complement. I will take this topic as a separate video. Don't worry about that. But rest of the things we have covered smoothly, and we have seen for example for each and every bit. So I hope you have got an idea of bitwise operators, right? So keep try some more programs based on this, and please ping me how did you like this video, and don't forget to subscribe my channel, and please click on a bell icon for your further notifications. Till then, bye bye.